All right, today we're going to dive into one of the most famous and, let's be honest, one of the most confusing brain teasers out there. I'm talking about the Monty Hall problem.
So, what's it all about? Well, it really just comes down to one single question. But man, this question has caused so many arguments and has totally stumped some of the smartest people you can imagine. So, let's get into it. Let's set the scene. Okay, so picture this. We're going back in time. We're on the set of a classic game show, Let's Make a Deal. And who's our host? The one and only, the legendary Monty Hall.
So, you're the lucky contestant. You're up on stage, and right in front of you, three big doors. Now, behind one of those doors is your dream prize, a brand new car. But behind the other two, you get what they called zonks. Something you definitely don't want, like a goat. Your job? Super simple. Find the car.
Okay, so here's how the game plays out. First up, you've got to choose a door. Let's just say you point to door number 1. Now, here's the key part. Monty, the host, he knows exactly where that car is hiding, and he's about to make a very specific move. He walks over to one of the doors you didn't choose. Let's say he opens door number 2, and bam, it's a goat. He always shows you a goat. And this is where everything gets interesting.
Right? So a door is open, a goat is revealed, you have new information now, but what do you do with it? This is it. The moment of truth has arrived.
So Monty turns back to you. He's got this little smirk on his face, The whole studio audience goes quiet. You can just feel the tension in the air. And then he hits you with the question. He looks you right in the eye and asks, so, are you going to stick with your first choice, door number 1, or are you going to switch over to door number 3? Seriously, what would you do here?
Okay, so there it is, your two options, stay or switch. Now, for almost everybody, your gut feeling, your intuition, is screaming, hey, there are 2 doors left, so it's got to be a 50-50 chance, right? It feels like a coin flip. It shouldn't matter what you do. That's what most people think.
Well, this is where the Monty Hall problem gets its reputation. Because that gut feeling, that totally logical-sounding 50-50 coin flip idea, it's completely, 100% wrong. Here's the mind-blowing answer. You should always switch. Every single time, switching gives you a way better chance of winning the car. And I know what you're thinking. Why? How does that even make sense? Okay, let's go back to the very beginning and look at the odds. When you made your first pick, you had 3 doors, so your chance of picking the car was 1 in 3, right? A 1/3 chance. That's simple enough. But here's the part we forget. That means there was a 2/3 chance that the car was behind one of the other 2 doors. Hold on to that 2/3 number. It's the key to this whole puzzle. If that still feels a little weird or counterintuitive, don't worry. There's a brilliant way to think about this. Let's just make the problem way, way bigger. I promise, when we scale it up, the right answer becomes screamingly obvious. Okay, instead of 3 doors, let's imagine 100 doors, a massive wall of doors. And just like before, there's only 1 car, but now there are 99 goats. Go ahead, pick one. Anyone. We'll just say you picked door number 1 for simplicity. So what are your chances now? Your odds of picking the right door on your first try are terrible. It's 1%, just 1 in 100. Which means there is a massive 99% chance that the car is behind one of those other 99 doors. Let's be real, you almost certainly picked a goat. Now here comes Monty, and he does something incredible. He walks down that long line of the 99 doors you didn't pick, and he opens 98 of them. And behind every single one, goat, 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 another goat. 98 goats in a row. He leaves just one other door closed. This is where you can really feel what's happening. Think about that huge 99% probability that the car was in that group of other doors. That probability didn't just disappear into thin air. No way. What Monty did with his special knowledge was he basically scraped up all of that 99% chance and funneled it, concentrated it, right behind that one single door he left closed. So now Monty turns back to you and gives you the choice. You can stick with your original door, your pathetic 1% long shot, or you can switch to this other door, the one that basically soaked up a 99% chance of being right. I mean, now it's a no-brainer, isn't it? Of course you switch. You'd be crazy not to.
Okay, that felt really clear, right? So now let's take that exact same logic, that same powerful idea, and shrink it right back down to our original game with just 3 doors. It's the exact same thing happening, just with smaller numbers. What we're seeing here is a cool concept called the concentration of probability. The odds for your first door, they never change. That's always a 1 in 3 shot. But that 2 in 3 probability that was spread out over the other 2 doors, well, when Monty opens one to show a goat, that whole 2/3 chance gets packed into the single remaining door. So here's the bottom line. If you stay with your first choice, you only win if you happen to pick the car right at the start. The odds of that? 1 in 3. But if you switch, you win if your first pick was wrong. And what were the odds your first pick was wrong? 2 in 3. So by making that simple switch, you literally double your chances of winning. Let's just boil it down one more time. Your first pick, it's always got a 1 in 3 chance it's locked in. What Monty does is give you a massive clue. He takes the 2/3 chance that was on the other doors and points you right to it. So when you switch, all you're really doing is betting that your first guess was wrong, which statistically, it probably was. You know, the Monty Hall problem is just such a great example of how our brains, our gut feelings, can be so wrong when it comes to probability. It really makes you think, doesn't it? What other things that feel like common sense are actually worth taking a second look at when you dig into the real numbers?